Okay, we just change our points. Right click on this and we go to the lined area survey. We chose ground. And then we will search and open the tool again. So tools, don't need this layer. Okay, I think it should be here. Our line area survey dataset to raster. Okay, so this tool, we search and open it and type that this raster uses a different interpolation type of triangulation that takes a little longer to process, but better interpolation. Better interpolates voids found in the Earth's surface. Now, the input data, of course, like previous one, we will choose the chapter 11 LAS data LIDA area survey data, and the name we will make it DTM. So DTM is D as the digital terrain model, and this we leave it as triangulation instead of binning. Is triangulation and natural neighbor interpolation method. Natural label thinning type, no thinning. Floating point and cell size, and sampling value will be 5, and z factor will be 1, and we will run the tool and close it after it finishes. So a raster surface of the Earth feature is created. So I'm gonna run. And we will create a normalized digital surface model in DSM, normalized digital surface model. So in normalized digital surface model, surface is the difference between the digital surface model and digital terrain model surfaces that is normalized to the bare Earth surface. And in the geoprocessing pane, we will search for the minus tool. Okay, we have the DTM that go to tools again, then we will type minus. So minus tool and 3D analysis tool. And the first one will be DSM and DTM. And then the output that I will say it's normalized digital surface model. Click run. And we will run the tool and then close it after it finishes. Now we have a raster surface that can be applied to point features used for buildings to determine their height. We will create random points for buildings. So randomly generated points are created for each building polygon, and then the normalized digital surface model raster surface is applied to each random point. So the point with the highest z value will be used as the building height. So now we're going to turn this chapter LIDA area survey dataset layer off and turn this building blocks layer on. Check on it again. Okay, so delivery data, no. Oh, just slow. Okay, now we can see it now. And in the geoprocessing pane, we will search for the tool back in here. We will search for the tool, create random points tool. Okay, I will say create random points, create random points. All right, perfect. So data management. Okay, all right. And we will type or make, so bridge random points. So output, it will be building blocks random points. Constraining features that we will use the buildings. That long, and it's 100. Number of points is long. Okay, we have a 100 minimum allowed distance linear units. And for minimum allowed distance, we will type 5 feet. And then we will run it. After that, when it finishes, so that we will turn all layers off except the building random points and zoom in. Click various random points on each building. Note that the 100 points for the US Steel building will have a CID value of 521. Every building has a unique CID, so value that we will use later to join to building footprints. Okay, now I'm gonna turn everything off for the layer. There. So I don't need the blocks and I don't need. Alright. Okay, so right here are the points. So yeah, there are the random points. Click various random points on each building. So we will click them. Okay, that's cool. So we will see the CID number if I go to right click on it, open attribute table. That we will see the CID number. Okay. Next, we will add surface information to random points. Here we assign the z height value from the digital surface model raster surface to each random point by using the add surface information tool. So now I'm gonna close this up and go back to Tools, Drill Processing Pan. I will find the add surface information. Add surface information 3D Analyze tool. And we will type or make the following selection here. So input for sure will be our building blocks random points. Okay. And then input surface, it will be our normalized digital surface model. Output probably will check the z method bilinear and sample distance, and z factor is 1. And now we're gonna run the tool and click vary random points and note that they now have a z values. The highest value for each building will be used for the building's height. So we add the surface information and right click on it, just open attribute table. I don't want to click on it. So now we should have a z-score. Perfect. And assign a maximum value height to random points. The summary statistic tool will calculate the maximum z value for all buildings using the building's random points. So a text file is created that we will join back to buildings using the CID unique value for each building. So the CID field. So in the drill processing pan, we will search for open the summary statistics. So go back here, summary statistics. Okay. Okay, then we have the summary statistics, and that we will type and make the selection. So input table for sure, that will be the blocks random points. And output table, I can just say in drill database that we will say building blocks, DG and heights. Okay, field will be z value, statistic type maximum, and case field that we're gonna use is CID instead of object ID. Then we will run, and then we have a table here. So now we open the table and sort. Open the table and we're gonna sort. So maximum z value and sort, we will say descending. Okay, so we look at this 512 is 872, A72. being the highest. So maybe feet, and we will close the window, close the table. And now we will join the maximum z-value height to building footprints and display as a 3D buildings. So in the contents pane, we will click blocks, join and relates. So now here is this one. Turn it on and go to joins and relates, add join. So joining the building using the building blocks field, building blocks. All right, so building heights, layer to join and view. No. All right. Blocks. Okay. And then building blocks ID. And then input, yeah, table is this one. And then it will be the CID for the join field. So if we are not sure, so we have a CID here, and then I open this attribute table. So let's look again. So we have, yeah, building blocks ID, and then the CID, building unique ID, should be the same. I just gonna descending it. All right, so then we have a 512 something there. No, it should be, yeah, the CID, okay, right here. All right, so now we have the join and click run. So now we will turn the blocks layer on and drag it to 3D layers in the 3D scene. So, okay, so now I have this building blocks layer and drag it into here, there. All right, so now I'm gonna, can I right click on and say zoom to layer? Yeah, there. So now I have to close out everything so we can see things better. And close, right? And I don't need this, okay. Okay, so now we can see the building blocks. And then we will have to go turn these points off, which I did, and use the 3D view bookmark. Go back to map and wait a little bit and go back to bookmark. I think it's thinking. All right. Go to project. All right, I'm gonna save it. All right, there. As long as I save it, it should be good, and we'll just wait for it and see why it's not showing, why it's grayed out. That's interesting. Okay, let's go to view. Even the view grayed out. I will find a way and see what's going on here. Oh, maybe I think it's this thing still here. Yeah, that's why. All right, bookmark. 3D view. Perfect. So you have to close out all those tables, okay? So now on the appearance tab, so click this and then I have the appearance tab. That once we go to the appearance tab, the extrusion group, which is right here, under type right here. So we will say maximum height and field. It will be max Z as the field. And then this require a lot of processing, but now we know we have a 3D buildings. Notice the residential building on the left of the view in the Mount Washington neighborhood, as opposed to the taller, higher rise buildings in the Central Business District neighborhood. So we have to wait a little bit for it render and see. Oh, it's not there yet. So there. All right. and we're gonna save it.